Hi, I'm Matt Leotta from Kitware. In this talk, I'll be presenting IARPA-funded research on the maximum radius of polynomial lens distortion. Many computer vision applications need to model the distortion of lenses. The polynomial radial distortion model is the oldest and still most commonly used model, often used up to the third degree, as shown here. There have been many other methods proposed, but since this one is so common, our focus is to understand the shortcomings of this model and help correct them so that applications focusing on this approach can make better use of this model. Here's an example showing the first, second, and third degree models estimated from OpenCV, and you can see that the first and third order models have artifacts. We aim to answer the question, why does this happen sometimes, and can we detect when it will happen? If we expand the range of this image, we can see it's not just the corners that have this artifact. Because the distortion function is a polynomial, it often doesn't increase monotonically, and there's a peak after which the radius moves back towards the center of the image. So this distortion function is only valid, it's only bijective, from the center of the image up to some maximum radius. And so our goal is to find this smallest positive radius such that the derivative of the distortion function is 0. Otherwise, the maximum radius is infinity. So we've developed an algorithm to compute this smallest positive root of a third degree polynomial. It's a closed form solution. The first and second degree solutions are trivial, but the third degree case is a bit tricky, and details can be found in the paper. So what are the implications of this maximum radius? Well, as we've already seen, this can affect the undistortion of the image, and undistortion will fail if the distorted maximum radius is less than the radius to the corner of the image. But that's not the only case. So any finite maximum radius can cause issues in the forward distortion problem. So this would be examples such as augmented reality, or any case where you're projecting 3D points into the original distorted image. So as an example, let's look at a long straight world line being projected into an image under a distortion model. So this camera has a valid field of view that covers part of the line, and that part of the line projects as expected into the distorted image. But as that line extends outside the image, you can see that it curves back and eventually crisscrosses right back through the middle of the image and passes out the other side. And what this means is there is an additional invalid field of view for which any point that lies in that field of view will erroneously project back into the center of the image. So this causes a lot of problems for augmented reality applications. So how often do these problems occur in the wild? Well, we did some experiments with the Lensfun database. So Lensfun is a collection of manually calibrated distortion models for commercial lenses. And this is used in production to correct for lens distortion in many different applications. There are 3 different models shown here in the Lensfun database. And we evaluated the maximum distortion radius on over 5,000 of these lens models across the 3 different types, and found that about 30% of the Lensfun models have a finite maximum radius, which means that they would have issues in an augmented reality application. So the next question is, how many of these Lensfun models are not valid over the full image and would have problems with undistorting the image? Well, in this case, just one. And that's not all that surprising because the Lensfun models are developed for this undistortion problem, and they're manually vetted before being added to the database. And so you would not expect any of these models to have that problem. So in conclusion, the polynomial radial distortion models often fold back on themselves. But it's easy to compute the maximum valid radius. And once you have this maximum valid radius, you can use it to detect when an undistortion will fail. You can also use it in the forward projection to filter out erroneous 3D points. Thanks for listening. If you have any questions, feel free to email me or my co-authors, or find one of my Kitware colleagues here at WACV. Thanks.